So our goal now is to take our point cloud, which currently looks like the shape of a cube, and our goal is to add a noise pattern onto it so that it goes outside of the bounds of that cube. And to do this, we're going to know another geometry node technique, which is getting to know our noise pattern and how to apply that. And first, step number one, we're going to get to know what not to do. Now, normally when we move things around in the 3D viewport, we can do things like the transform values. So we might think that we might want to use the transform node that actually is built into the geometry nodes. But we'll notice that we have a problem when we use this node, and that is everything is actually being moved all together. Why is that? Well, at this point, you might say, okay, well, we're only working with one value here. So if we throw down a noise node and plug it into that translation, we should be able to start to see something, but we're going to run into another issue here. If I take my color of my noise, plug it into transform or translation, we'll notice that we get a big red line that's happening here. So why is this happening here? Why isn't Blender letting us do this? And if we want to move these things individually, how do we end up doing that? And that brings us to step number two, which is to get to know how fields work inside of geometry nodes. So fields, this is going to be a brand new definition for us to get to know. And Blender's going to give us some hits in terms of the shape of the socket. We'll notice that on the noise texture node, we have a diamond shaped socket. And then on the transform node, we have a circular shaped socket. So what is this? What are we doing here? Why is this important? The diamond shaped socket is a field, and the circular shaped socket is not a field. So what exactly is a field? You can think of a field the same way you think of like an agriculture field, like a wheat field. There's just a lot of stuff in there, right? And what a field does in Blender is instead of us working on an object level, it's going to be working on an individual point level. And in this particular case, because this field is being plugged into a geometry network that currently has instances, we're going to be able to move the instances around individually by using a field. And that brings us to our next question, which is, okay, well, what nodes allow us to move things with fields? And that brings us to step number three, which is our set position node. So I'm going to delete my transform node. And where do we actually find nodes like this? If we go to our add menu, we go to geometry. So we have our set position node right down here. And in this particular case, we're going to use the set position node. I'm going to plug my instances into geometry, and then geometry into geometry. So we're plugging instances into the geometry node, and you'll see that it's working fine here. Generally speaking, whenever we see geometry, usually that encapsulates all different geometry types, meaning mesh, curve, point cloud, volume, instances, etc., etc. And now we'll see that, okay, now we have some diamonds to start working with. Specifically, we're going to be working with offset. So we're going to be offsetting the original position using our set position node. So I'm going to plug my color into offset. And immediately we start to get some randomization happening here, but not really much. We can see a little bit now. If we look in the top view here, we can see, okay, that line is now being broken up. See, it's straight line right there without it disconnected. Plug the color into the offset. Now it's going to be offset a little bit. We want to exaggerate this. We really want to push this beyond that bound. Now, at first you might think, okay, well, we come in here and we might just want to adjust the scale, right? We just make the scale bigger, which is going to mean it's going to go more, right? Well, not in this case. Scale in the noise texture node, the way it works is it adjusts the frequency of this noise pattern. So right now we have a frequency that looks something like this, and it's currently set to 5. But if we increase the 10, the frequency is going to look something like this, right? It's just more frequency within that noise pattern. And what we actually want to do is we want to take this 5 value and just exaggerate it like this. So how do we actually do that? Well, we can do this with a simple multiplication. So if we think of this line as a 0 value, right? So we have 0 in the middle, and say we have a value of 5 on the edge. So we have 5 here, and then we have -5 here. If we just simply multiply any of this value by another value, say like 5 times 10, we're just going to be making that value a lot bigger, right? So we're going to need to introduce a new node. We'll go to our menu, go to our submenu, vector, and we're going to get to know vector math. So what is a vector math? What are we doing here? A vector is just a three values here. So offset, currently this is a vector. Same thing as our location and our rotation and our scale. These are all just X, Y, Z coordinates. And because X, Y, Z has 3 values, they are considered to be a vector. We'll talk more about that as we go. So I'm going to click on my vector math, connect in between the noise texture and our set position. Now we could use multiply here, but what we're going to do is we're going to switch this over to scale. And the nice part about scale is it's a simple multiplication, but it's going to be applying the same value to X, Y, and Z, right? So now when we go up on this, we'll we'll see that we're getting more of that randomization. I'm going to leave off the value of 4 here. Now we can see, okay, now that straight line is completely blurred. We can't really see it at all because it's going further distance there. But now we have another problem in the fact that the noise pattern is pushing it in one direction. So if I do a before and after, it goes from being at the origin to being really pushed out all the way over here. And that brings us to step number 4, which is fixing that offset. So what is happening here? Why is this happening? Why is it, just pushing it in one direction? Well, this noise texture, it generates a noise pattern based off of 0 and a 1 value, right? So black and white. Black meaning it's 0, white meaning it's 1, and then it has a lot of gray areas in between here, which means it's only going to push it in a positive space. But what we needed to do is have it to go negative space as well. So how do we do that? Well, before the scale, before we actually make it bigger, what we need to do is offset this. So we'll just grab another vector math, vector math, click and add it. And now what we'll do is we'll just add a negative 0.5. And then there we go. So where did I get this magical number 0.5 from? Specifically the negative 0.5. 0.5 is just half of 1. So 0 to 1, black and white. 0.5 is that perfect gray value. And now we're doing it in a negative value, which means it's going to offset it, offsetting for the fact that that noise texture was only going in positive space. Great, and we'll have the full node cheat sheet in the cheat sheets below.